All right, so this is a problem that you guys asked about. We were asked to find the critical values of this. So first of all, I need to know what critical values are. So critical values are spots where the derivative, so g prime of t, would be equal to 0 or undefined, right? So 0 or undefined. That's what we're looking for. That would give us our critical. So then if I'm going to find my critical values, what I really need to find is I need to find my derivative, right? So let's go ahead and work on that. Now, before I find my derivative, I really don't like how g is structured. So let's go ahead and analyze the structure of g. So first of all, I notice it's a product, right? And then I also notice that I'm going to rewrite this next piece as really being a 1/2 power. That's just going to make it easier for me to see. So then it's a product, and I know I have to use right, the product rule, and then I also notice, I'm going to have to use chain rule here, aren't I? Chain rule in there, because I've got an internal function and then an external function, right? So definitely going to have to look at my chaining. All right, so let's go ahead and get started then. G prime of t equals, t multiplied by, and I'm going to take the derivative of that second piece, 4 minus t to the negative 1/2 multiplied by -1, right? Because that's the derivative of the inside function. And then I would add, right? Like I'm going to add the other, so this is part of my product rule. I've got one big part of my product rule here. Here's going to be my other big part. And that would be 1 multiplied by 4 minus t to the 1/2. Now this is all well and good, but it doesn't look usable, especially if I'm going to find when the derivative is equal to 0. So let's go ahead and kind of change those exponents, right? Let's change it back. Let's change the form to a more usable form for us. So I know that I'm going to have, a negative, right? And so I can put that kind of negative anywhere I want. And I'm going to have t in my numerator, and then I'm going to have 2 in my denominator because of the 1/2. And then also because that's a negative 1/2 power, it means I have the root of 4 minus t in my denominator there. And actually, maybe I'm going to go ahead and take that negative and I'm going to shove it up top. I guess I can, because I'm forward thinking. I'll explain when I get there. And then I have add, that's just the root of 4 minus t. So this looks better, but I'm going to set this equal to 0. So I'd love it if it was all one thing, right? All one thing. Because if I set this equal to 0 now, it's going to be tough for me to maybe it wouldn't be too tough to solve. I could solve that, couldn't I? But I'm still going to clean it up because I'd prefer to do that. So what I'm going to do is I'm going to go ahead and get a common denominator, right? So, right, I can multiply by 2 root of 4 minus t, and multiply that by 2 root of 4 minus t. And then we're going to get, when we do that, right, we're going to get negative t, and then plus, and that'll be, that'll be 2 times 4 minus t, because those roots will just cancel out. That's going to be all over 2 root of 4 minus t. Which, if I simplify even more, I could write it as, let's see, negative 3t plus 8 all over 2 root of 4 minus t, right? No big deal. Now, keep in mind, I was looking for the critical values. This was my goal here. I don't want to lose sight of that. So if we go to start working on that goal, I really want g prime to be equal to 0. Now, if that's the case, then that just means that my numerator would be 0. So that means that I could set that equal to 0. And when I solve this, I'm going to get, 8/3, right? But also, I need to look at when it's undefined. So what if g prime of t is undefined? Well, what would cause that to happen? Well, that would be if my denominator of my derivative was 0. So what if 2 root of 4 minus t was 0? That really just means root of 4 minus t would be 0. That really just means t would be 4. So that is a critical value, and that is a critical value. And we have now found both of the critical values for this function.